Hello laser hobbyists, this is Chris in Doha, Qatar, back with another video. Today I'm showing you a very inexpensive spectrometer. This was built by Chris Wesley in the UK. He has a website. There's a link to it. I'll give you the directions to the link. And the price was very, very low. 85 pounds for the base version. And the accuracy, although stated at plus or minus 2 nanometers, was a lot better than that for me. Maybe I just did the calibration really well and waited long enough to warm up about 15 minutes and it stops drifting. Anyway, here's the software. It's the Theramino, I think I'm pronouncing that correctly, software. It's open source and you can download it for free. It's not associated, as far as I know, there was no development of this software by the maker of the i-Phos HD spectrometer, this here, but anyone can use it. It's free and it works very, very well. You can aim the spectrometer at a light such as that fluorescent light up there and you'll get some spectral lines that are always the same. Two of them are the 436 mercury here, and there's actually two mercury peaks over here. I have it on the right one, which is 546 nanometers. You can see the internal camera is showing the pattern from the diffraction grating that's inside the tube. That's the spectrum of that light bulb. Okay, I want to introduce you to something. This is a forum. It's a brand new forum. They got some great members already in it. It's Laser Discourse. I'm going to go ahead and open that. And they're a .org, laserdiscourse.org. And I have placed a review of the spectrometer there. Right here you'll see the YouTube video that the manufacturer made as an introduction to the spectrometer. It's very good. And then I have a write-up down below. See if I can scroll this. All right, here's my review. There's a picture from the manufacturer's website. It comes in several colors. Red's one of them. Obviously, I have the gray one. And you can get black or green. I believe he has another color. You'll have to go to his website to see the options on that. Here is a screen capture of another plot from a fluorescent light source, and what this shows is how you can line up the calibrations here and here for those two spectral lines. The other ones in here, they move around from bulb to bulb. They're not always the same, but the 436 and 546 are. I'm gonna scroll down some more. Okay, in this review, I was comparing the i-Phos HD to a professional spectrometer, which they really go for around $1,600 for the cheapest decent one I could find, made by LaserTech. I came up with 5 pros that I really liked about this unit. Number one is it's inexpensive, vastly less expensive than a professional spectrometer. That's number one. After that, I go into the advertised accuracies, where actually I measured better than plus or minus 2 nanometer. I was really measuring 1 nanometer, and right in the middle of where it should have been. So that's like no error in my measurement for that one. Another plus is the calibration sources. It's just an inexpensive, easy to obtain fluorescent bulb, which we talked about. The software is free, the spectrometer software. The cons are that a professional unit has less drift for wavelength, but after this warms up a few minutes, I don't see drift anyway, so that's moot. This has slightly less resolution, let's say, than a $1,600 spectrometer. Advertised resolution I saw on a LaserTech was 1 nanometer, and that was like $1,600, more than that actually. They have a model that's rated for better than 1 nanometer accuracy. Same price, but the spectrum is limited from 300 to 1,000 nanometers. So the more accurate these get, typically the tighter the bandwidths are. I'll go ahead and scroll. I have a little bit of information on the operation here. One thing I'm showing is a 405 nanometer diode that I was pushing a lot harder than the manufacturer's specified output, which is 300 milliwatts. And I pushed it 1.5 watts. Now, I'm not the first person to do that. These diodes are known to be able to produce 1.5 watts. And the spectrum that will shift, it goes up to 411, which I measured when you push it that hard. Here's another screen capture of a cheap 532 nanometer pointer that did not have an IR filter in it. You can see both the 532 nanometer green output on the left and the pump diode at 808 nanometers on the right. Notice that, well, I don't know if you can see it. There you go. On the bottom, 532 right in the center. Pump on the right, 808 right in the center. Those are the wavelengths. So that's right on. Because this has a web camera inside of it for the spectrometer, and using this diffraction grating as a pseudo line camera with the software, you get the frequency readout. But the difference between a line camera and a web camera being used this way is the spectral response is not flat. Right in the middle here is the visual range, and on the ultraviolet and the near infrared, you see it rolls off really fast. But that's what the eye does. That's why the camera was designed this way. It was supposed to mimic the spectral sensitivity of our eyes, and that's exactly what it does, and does it well. But since I bought the spectrometer and what it's sold for is to measure wavelength, we don't really care, except that for some sources, if they're very weak, the lower sensitivity might make it more difficult to measure. I have some remedies for that in the text here you can read. Here is a 1064 nanometer spike that I measured. Now this spectrometer is rated to 950 nanometers, but I measured this right on frequency at 1064 nanometers. That was this jet laser pointer. It's a DPSS, so it's going to produce 1064. And that's exactly what it measured after calibration. So that was great. Right on the money. Here's a calibration source, a fluorescent lamp. They come in different shapes, different packages, but that's what one of them looks like, and they're cheap. A couple bucks and you have a calibration source. There again is the spectrum of this type of fluorescent lamp. And my summary is this. Although made from inexpensive materials, I have no reason to purchase a $1,500+ spectrometer when the i-Phos HD can perform so well at a fraction of the cost using well-developed open source software. That would be the Thermino, if I'm pronouncing it right, software. So that's the review. I would sure like to see some of you go on over to the laserdiscourse.org forum and register. We just started it, and we have some great people there that just joined the forum, and it would be really wonderful to see some more activity starting up there soon. That's all from Chris in Doha. Cheers.